Hello and welcome to another lecture of classical motion of a single particle. In this lecture, we just continue our discussion on the motion of central forces. Okay. In the last lecture, we discussed how the orbits of the particles moving under central force can be derived by just knowing the force law and also the vice versa. That means, just by knowing the orbits, how can one derive the force law. Actually, we derive two equations, one is involving the r and theta and their derivatives, which we actually saw is much non-trivial, because it was a second order equation, non-linear equation involving the squares of dr d theta. And then we just said that there is an easy way out to have a much simpler form of equation, which we call the Binet equation, where we substituted this r variable to 1 by r variable, which is a u variable, and we actually finally showed that in terms of u, you will have an equation which is d2 u d theta 2 plus u is equal to minus f of 1 over u m h square u square. Just for recalling, this is the force law in terms of u, and actually this is the force law as a function of r, that is why I wrote it as 1 over u, and this is the constant of motion, this is also a constant of motion, this is mass, this is the angular momentum per unit mass h. Okay. And we showed that this is also very interesting to note, two different trajectories can actually be obtained from the same force law, which is, and I just said that for the sake of simplicity to admit the fact that this actually comes due to the different constant in the force. Okay. Now, I told you to think about the main reasons of that. It will be actually much more clear when we will discuss next week the inverse square law force. Okay. So, you see that here today I will again tell you that if you remember that both for the trajectory like r, it is equal to some e to the power theta, and I think this was the correct one, right? Yeah, r was e to the power minus theta, yeah, e to the power minus theta, and r theta is equal to some constant we had f of r proportional to 1 over r cube and attractive. Now, whether they are, how to understand that they are attractive, that is also depending on the constant of proportionality of f. Okay. So, this is also something we cannot say in general in advance, but for example, I just want to take back this original proof or demonstration once again. For example, this one, I said that this r theta is equal to k, and that is why this u is equal to k minus 1 theta, okay, and I call that u is equal to k prime theta. Then I said that this du d theta is equal to k prime and d2u d theta 2 is equal to 0. Okay. And then you actually have this u over here, and d2u d theta 2 is 0. So, Binet equation simply said this is equal to minus f of 1 over u by m h square u square. Now, you see that this becomes actually minus f of 1 over u is equal to m h square u cube, okay. And then this is nothing but f 1 over u is equal to minus m h square by r cube, whether you can write this as, where you can write this as r. Okay. Now, this one is positive because this is mass, and this one is again positive. So, you see that this f is of course is equal to some minus quantity, some negative quantity by r cube, and that is why this is attractive. Okay. So, whenever in future you will calculate the law of force from a given trajectory, you should be very careful that can you actually claim this is as attractive or not. Okay. You will actually see in some situations you cannot conclude whether this is attractive or not, okay. But here this is not the case. I am going to another case, r is equal to constant. You all know this is the case of a circular trajectory. So, r is equal to constant simply tells me that u is equal to also constant. Okay. R is equal to constant, I can say a. So, u is equal to constant is equal to 1 over a, but in both cases du d theta is equal to 0 and d2u d theta 2 is also equal to 0. Then Binet equation gives u is equal to minus f of 1 over u m h square u square. Okay. Again minus of f 1 over u is equal to I would just say that m h square u cube with a minus sign, sorry, with a plus sign here, because this is already minus, yeah. And then finally you will have this thing, and you can say, oh, this is exactly the same situation as this thing, that r theta is equal to constant. Well, here there is a subtle difference. Whenever we have a circular orbit, we have a cubic law, it is true, but this is a constant force, because this is not for any u. You see, this u is actually constant, it has a constant value which is nothing but 1 by a. So, finally, your f will be, f of r will be nothing but minus m h square by a cube. So, again if you now see, this is nothing but the centripetal force and constant. Okay. So, this is also a, if you can now understand as a cubic law, okay, inverse cube force law, this is okay, but this is inverse cube force law for a given value of a. Now, here there is a trick. Actually, you can also think this whole thing, this whole expression as minus h square m by a times 1 by a square. So, if you just say, well, this is my constant, new constant, because a is a constant, this force law can also be considered as minus of another. So, this can be, now I can call it as k star. So, this can be actually be minus k star by a square. So, it can also be seen as an inverse square law, okay, at a, but with this constant, proportionality constant is being different. So, what is the paradox here? So, is it just giving me that you cannot actually, for a circular orbit you cannot use Binet's equation, or it is actually true that you can go to 1 by a square, 1 by a cube, and even you can now say, okay, it can be actually 1 by a as well. Okay. If you just absorb one more a from here to here, it will be another constant k, let us say double star, and then you can have 1 by a. Okay. You can do even the fractional powers of a as well. So, I invite you to think about this. So, in this course you see, I will tell some information, I will share some information, I will also try to teach you some, I mean there will be no approach of teaching as such, but we will learn together, but I will somehow try to learn with you guys something, but it is also true that we will also I will also be sharing some questions or some food for thought for you. So, if you understand this situation and if you have some way to solve this paradox, you can also let me know in an email or in the forum discussion. Okay. Okay. I am going to this another part, that is the case how to find the trajectory or orbit if I know f of r or f of u, actually 1 by u I just write, okay, f of u. So, let us consider this situation for a very well known situation, that is our well known. So, let us consider the case of familiar inverse square law. That is f r is equal to minus k by r square, okay, and the whole force is actually minus k by r square r cap. Okay. If you have this thing, then of course, you know d 2 u d theta 2 plus u will then be equal to minus. So, this is nothing but equal to minus k u square. So, this will be minus k u square by m h square u square, and these 2 u squares will go away, thereby you will have minus k by m h square, and you can now say this is a constant, because k is the constant of proportionality, m you know constant is the mass, this is the angular momentum per unit mass, which is also constant. So, I can now say let us, so I can actually write this d 2 u prime d theta 2 plus u prime is equal to 0, where my u prime is equal to u plus k by m h square. Okay. So, let me just check whether these symbols are all okay with these conventions. Yeah, u is equal to u plus m h square, very good, yeah, perfect. Okay. If you have this, then I actually know what is the solution of this equation. That I know from my experience trial solutions. I know u prime will be equal to some a cos theta plus b sin theta, trigonometric solutions. Okay. Then I know also that u plus k by m h square is equal to a cos theta plus b sin theta. Okay. Then you also know that this u is equal to minus k by m h square plus c cos theta minus theta 0. You now know from one of the previous lectures that if I have this form a cos theta plus b sin theta, you can choose some c theta 0 and theta 0 in such way that c square, so is equal to, actually if you write this, so this is not a very difficult thing. Which you have to do is that you have to write where a cos theta 0 is equal to, I mean c cos theta 0 is equal to a and c sin theta 0 is equal to b. Okay. So, by this way you can write this, and then since u is nothing but 1 over r, then r is nothing but 1 by the whole factor minus k by m h square plus c cos theta minus theta 0. Okay. Now, you see, if k is less than 0, then so we just go to the previous discussion. So, this is actually f r is equal to minus k by r square. I take okay. So, I think I have made a mistake. I have to write from here some correction, so that this is consistent. Otherwise, yeah, I just take this one. Otherwise, because in Binet's equation, yeah, in Binet's equation there is a plus sign over here. Okay, this is sorry, there is a minus sign here. So, this is exactly, this is equal to minus f of 1 over u. Yeah. So, if I already, and by m h square u square. So, if my f is k by r square, then only this is the correct expression. Otherwise, I have to change everything. Okay. I also change the sign over here to get consistent with my later versions. Okay. Now, this equation is attractive when k is less than 0. I am now saying like this. So, if k less than 0, then f is attractive. Okay. And then I know that minus k by m h square is also less than 0. Okay. So, what I can do, I can actually write r is equal to minus m h square by k by 1 plus, if you just check this, minus m, I just multiply the numerator and the denominator both by minus m h square k, and that will be minus m h square by k times c times cos theta minus theta 0. Okay. I can call this thing, something which is actually greater than 0, because k is less than 0. I can call this thing as p, and I can call this that 1, and again k is less than 0. So, this one c is, I am just thinking that c can be actually positive as well, and so this is again greater than 0. So, I can write this plus epsilon. So, epsilon is nothing but epsilon is equal to, I would write minus m h square c by k. Yeah, epsilon or e, I just write epsilon, that would be easier because epsilon is the standard notation, many books write that. Yeah, cos, just a minute, cos theta minus theta 0. Okay. If I write this, then this is actually the equation or the orbit or the trajectory of this particle. So, the orbit is given by, in polar coordinates, r is equal to some constant p by 1 plus epsilon cos theta minus theta 0. You can say that I can actually start to calculate or measure theta from this theta 0 to be equal to 0, and then this is a constant, you can choose this, and then you can actually say that r is equal to p by 1 plus epsilon cos theta only. Okay. And this is the polar equation of a conic section. So, Just by using Binet's equation, you can show that if the force law is inverse square and attractive, then the trajectory has a shape of a conic section. Now, conic section may be like elliptic, the conic section may be hyperbolic, the conic section may be parabolic or circular. Circular is a special case of being elliptic. Okay. And so, we will see next week that depending on the various parameters and the various constants of motion, it can change the nature from one to the other. Okay. Thank you.